6, it's about inverse trigonometric functions. Let's try to understand inverse of trigonometric functions. Y is equal to arc sine x is the inverse of sine x, right? You can get the graph of this by looking at the graph of sine x and drawing the y is equal to x line and taking the mirror image of that. And this is the graph of arc sine. That's how you get it. That's the inverse of sine. Okay, see, look at the title. The title says domain restrictions that make the trigonometric functions one-to-one. Usually sine x is not one-to-one, but if you restrict the domain to negative pi over 2 to pi over 2, and if you apply the horizontal line test, it passes. So y is equal to sine x is actually one-to-one on this interval. Cosine x, on the other hand, is invertible or is one-to-one and invertible in the domain 0 to pi. Look, apply the horizontal line test, you get it. And then tangent x is one-to-one in the negative pi over 2 to pi over 2. Look, apply the horizontal line test, it passes the horizontal line test, so it has an inverse. Since these functions in that restricted domains, they are one-to-one, they have inverses. So what are the inverses then? The inverse of sine, we already said that in here. This is the inverse of it. If you see, if you take the mirror image of this along y is equal to x, you get that picture. You get this picture, okay? And then you can do similarly for cosine. And let's see. Probably in the next graph it's gonna say that yeah, it's explaining it. Let's look at cotangent x. Cotangent x is one-to-one on 0 to pi. Look at that. And secant x is one-to-one on this separated domain 0 to pi over 2 to pi over 2 to pi. Okay, pi over 2 is not included. And cosecant x is also invertible in excuse me, in the domain negative pi over 2 to pi over 2 except 0. Okay, so they have some inverses. Here's the sine x again. It has an inverse. Look, you use the mirror, you take the y is equal to x, draw it here, and take the mirror image, you get the inverse. See, the domain becomes the range of this, and range of this becomes the domain of this. Do you see the switch? And these are the summary of the inverse functions. This is the inverse of sine, this is the inverse of cosine, this is the inverse of tangent, this is the inverse of secant, this is the inverse of cosecant, this is the inverse of cotangent. Okay? You don't have to memorize, but if you need it, you know where to find it. Y is equal to arc sine, and this is just giving you the definition. Y is equal to arc sine x is the number in this interval where sine y is equal to x. Okay? Y is equal to arc cosine is the number in 0 to pi for which cosine y is equal to x. Okay? This is just explaining sine and cosine, sine and arc sine. Excuse me. The inverse is an angle, right? For example, sine of theta is equal to y, but arc sine of y is a theta. So, in other words, sine takes an angle and gives you a number. Arc sine takes a number and gives you an angle. That's why we have such a picture here. Similarly for cosine, take the mirror image, you get such a picture. This is the image. See, the domain of cosine becomes the range of cosine, arc cosine. The range of cosine becomes the domain of arc cosine. Here are some practices. For example, you ask yourself, okay, sine pi over 3 is square root of 3 over 2. Then you're gonna ask, then arc cosine of this is going to be pi over 3. Look, arc sine of this is going to be pi over 3. Similarly, you know cosine 2 pi over 3 is negative 1 over 2. This would mean for us arc cosine negative 1 over 2 is 2 pi over 3. So they are inverse of each other. Okay. And so there are more information here, which I think you don't need it now. They are giving you the definition for arctangent. Y is equal to arctangent x is the same as tangent y is equal to x. Y is equal to arccotangent x is the same as cotangent y is equal to x. Y is equal to arcsecant x is the same as secant y is equal to x. Arccosecant x is equal to y is the same as cosecant y is equal to x. Of course, assuming that they are in proper domains. Yeah, this picture tells you that at 1 and negative 1 we have vertical tangents. At x is equal to negative 1 and 1. Okay. Pardon. Therefore, actually, since because of the vertical tangent, you don't include 1 and negative 1, so we are interested in the derivatives of arc sine. So we have to look at the points where you don't have the derivatives. For example, here you have the vertical tangents here, right? So we exclude them. So the derivative of arc sine at u is 1 over square root of 1 minus u squared du dx. The absolute value of u is less than 1. So this is the derivative of arc sine. The derivative of arctangent is 1 over 1 plus u squared du dx. So let's look at the arcsecant. For x greater than 1 and x is less than negative 1, the slope is positive, it says. I think we are going to skip that. We don't need too much of it, but we should know at least 1, 2, 3, 1, 2, 3, and 4. 1, 2, 3, and 4 you should be aware of. Okay? These are the derivatives of the inverse functions. And since we know the derivatives, now we can think about the integrals. Integral of the inverse of arc sine is going to be this. The integral of the I should say the derivative of arctangent was 1 over a squared plus u squared, then integral of 1 over a squared plus u squared is 1 over a arctangent u over a plus c. Okay, and let's see, arcsecant did we, no, I don't, I just want you to know 1 to 4. Okay, you just need to know first 2. First 2 is fine.